Good morning, everyone. It's Alan Yu here. I'm the product manager from Cambium, responsible for 820 product line. And today we're going to do the PTP 820E E-band product introduction. So let's wait for 1 or 2 more minutes to see get more people on board, and then we will start. Okay, it's right now the central time is 1 minute past 9 o'clock. We're gonna wait for 1 more minute, and we will start at in 1 minute for the 820E webinar. Okay. Good morning again, everyone. It's Alan again. So let's start. So today we're going to cover the 820E, which is our E-band radio covers from the E-band 70 to 80 gigahertz frequency, provide high capacity. So let's look at what the 820E is. Next slide. Okay. So this is the 820E. It's a full outdoor radio. It's a single radio. It's compact size, running for IP. We're running 71 to 86 gigahertz, provide full duplex for 2.5 gigabits throughput. The radio has, running on all different channel size. Actually, we can running pretty low frequency, low channel size, down to like 14 or even 28. 14, 28, 50, so 40, 50. For any frequency below, any channel size below 62.5 megahertz, we can running on 1K QAM. So on the 62.5 megahertz, if running on 1K QAM, you will be able to get 500 meg full duplex throughput from the radio. We can also support wider channel like 125, 250, and 500 megahertz. When the channel size become wider, the modulation will downshift a little bit. So on the widest channel, on the 500 megahertz channel, the radio will support 64 QAM. That will provide 2.5 gigabits full duplex capacity. And the radio has two versions. One is the connectorized version. Basically, we will offer direct mount antenna for 1 foot and 2 foot, and to form a solution. Or we also offer integrated version. It has a flat panel antenna. Basically, it offers it's a 1 foot. It's 43 dBi antenna again. It's a 1 foot dish, but it's more compact size with a built-in antenna. The radio support 1+0. You can also in the future we will also put the hot standby things in the future, but right now it's only do 1+0. You can put two radios together with a single pole with a splitter or a coupler to do a single pole or dual pole. But for when you do a two radio together, you can't run XPIC. So it's basically just put two radios together, and then you can do the aggregation. Um, with the A20E, you can run either one cable using the internal switch to do the aggregation, because the radio do have the GIGI SFP plus interface. We also can do the using the external switch to the external link aggregation. So that's the kind of configuration you can support. The radio, as we're going to cover a little bit more details on the interface. So just keep in mind, we do have the 10 gig SFP plus interface supported. With the radio itself is a E-band radio, but also we have the radio offers layer one aggregation. Um, so I can put another micro radio together with E-band, so I can run a multi-band configuration. The multi-band configuration will basically using the microwave not only provide some additional capacity, but also in the case when I lost the E-band due to the rain fade condition, and the microwave link will still survive. We're going to cover that the benefit for multiband as well in more details later. This is the A20E. It's a full outdoor radio. We also have another platform called A20F. The A20F is a split mount radio with E-band support. What we could do is we can put one side with a full outdoor single unit, the A20E. On the other side, we can put an A20F with RFUE ODU, and those radio can talk to each other. So there's interoperability between the A20E with RFUE. So this is what A20E can do. Here is a more detailed summary about what the radio can do. So let's go over quickly about some key components. We said earlier we can do 1 +0, 2 +0 using the coupler or splitter, and you can share the antenna. And the radio today is hardware ready for XPIC, but the software is not yet released. So today with A20E, you can't do XPIC, but it will be supported in the future. The radio has, we talk about two variations. One is the connectorized, one is integrated version with a 1-foot dish. But in addition with that, just from the interface point of view, we also have another two options. One is we call ESE option. The other one version is ESP option. So the ESE stands for basically this is already specified the user interface. The ESE stands for electric, is a GIGI port. S for SFP, and E is for another electric port. And the ESP is electric, is a GIGI port, 1 gig, the SFP port, and the SFP plus interface. I show you some more details because the different version has different, not only the physical interface is different, but also there is some restriction or how you're going to deploy the radio. We offer both options for PoE input or DC input, so you can make your choice. We also have a mini adapter. You can using the PoE port, but using the DC as a power feed. The networking, it has a built-in switch. The A20E share the same switch like all other A20 product line, the feature function wise. We can support smart pipe the mode or CT mode, so you can do the layer one. Smart pipe basically is just a layer one point to point, and CT mode you can do the layer two service to make the different service connection, point to multi-point or point to point or multiple point to point. And also we support all other features like the A20, all other A20 line from QS point of view, frame cut-through, header deduplication. So all of those are the same. So if you have any experience with A20 today, when you move to A20E, It's pretty much straightforward. You will only the only thing really different is you will see the radio works on a different frequency. Of course, it's offer a much higher capacity compared to 820, but from UI or system setup, they're literally the same. You will have a pretty easy, you know, catch up to know how to run the 820E. So let's talk a little bit more about the interface here. So when you burn the radio, so let me get a pen laser here. So this is the radio. When we lay down the radio, you can see there's 4 port here, port 1, 2, 3, 4, and this is side view. This is the antenna port. It will be connect to the antenna. We offer the direct mount antenna for 1 and 2 foot, and this is on the other side of the radio. So basically, there's a RSL indicator, and the grounding is here. Okay. So let's talk about the user interface. We have 4, port 1 to port 4. As I said earlier, there's 2 options for the hardware. One is ESE, one is ESP. So let's talk about ESE first. So ESE stands for electric, SFP, electric. The last one is this is you know the port 4 is for future stuff when we do with the 1+1 or XPIC. So for ESE, this radio gave you the best solution or the most cost-effective solution for a single 1 gig solution. The reason is you do using the same cable for both PoE and also for data. So you run a single gig cable and you run connector radio. This is a very simple way. The 820E can do the ESE version can support the radio support 2.5 gig, but if you want to put more data from the radio, you need to put additional cables because this radio, the ESE radio, do not have the SAP Plus interface. So if your radio running on 2 gig or more than 2 gig, you're gonna running on additional cables. Either you run the SAP cable, put the SAP there, running either fiber or copper, or the SFP slot also offer another one called CSFP. It's a pair of SFP inside. So if you want to put a full capacity there, you just need to add the additional cable so you can put more data. The third port, the port 3, this is a management port. It doesn't carry user traffic. It's purely for management. So if you're running outbound management, you can run on port 3. So if you're running for ESE, basically as I said earlier, this gives you the best solution for if you're running for up to 1 gig because it's single cable solution. Okay, so let's compare with ESP. The ESP stands for Electric SFP and SFP Plus. Basically, the port 1 is the electric port, but this port is used for management. Okay, this port is not for and PoE, but it's not for user data. The user data has come from port 3 or port 4, port 2 or port 3. Port 2 is the same SFP port. It's only a 1 gig as a fiber interface or copper interface. The port 3 is SFP Plus with a 10 gig interface. So if you're running radio for more than 1 gig, you can using the SFP Plus interface with a single fiber to give it all the capacity, and then you also need a cable for either a DC input or a PoE input. So you're gonna do a 2 cable solution for 2.5 gig. If you're if you want to run a single 1 gig, the ESP doesn't give you the best option because you still need a PoE, and then you need another data cable for the data. So that is why the ESE gives you the best option for a 1 gig solution. All right, I want to play back again. Let's compare now the ESE and the ESP. So for ESE, If you're running 1 gig, up to 1 gig, you only need one cable. If you run on ESP, no matter what capacity you want, you always need two cables because one cable is dedicated for management and PoE. The other cable is dedicated for the traffic. So that is why the ESE is better for 1 gig below. You could run a higher capacity, but you need additional cable to run that. All right, and ESP is the best option for running a radio more than 1 gig because you're running one for DC input or one for power and one for data and using SAP Plus interface. That's really the difference. Price wise, they almost have the similar. I mean, their list price almost the same. So really, you're not saving on the radio itself. It's more about cables. But because the more cable you run, especially when you run the copper cable, you're gonna have the light surge protector added, so that start add additional cost for your system approach. That is already the difference when you should choose ESE and when you should choose ESP version. Okay. This is the part number for the radio. You can see for each variation we have one is connectorized radio and one with built-in antenna. It's a 43 dB antenna. So this is the ESE from 6A to 9A. This is ESE for version, and from 2A to 5A, this is the ESP version. Here's how the radio looks like. If you go with the connectorized radio, so basically we offer the direct mount antenna, and you will be able to mount the radio on the back. This will be the whole thing. The whole thing looks like. We also offer the built-in antenna. It's a 43 dB antenna, same antenna again like the 1 foot, but you can see it's smaller. Although they're all same antenna again for 1 foot. If you go with the 1 foot dish here, but this one because of the integrated version, it's much smaller. And also for this integrated version, we offer a special mounting bracket. It will make the alignment much easier because the mounting bracket offers fine tune when you're getting close to the direction. So that will give you a benefit. If you go with the lowest cost solution is the connectorized radio with the antenna. The antenna mounting bracket is like this. So it's a little bit challenge on the alignment because 80 gigahertz has a very narrow beam. So you need a better alignment, or you be more patient when you align the radio using people using scope or laser trying to align the radio quickly. But that is basically you need extra, you need more patient to do the alignment. So that's the difference between the direct mount and integrated antenna version. So here I want to show two examples. One is using a 1 foot dish, and another one will be a 2 foot dish. This one is 1 foot dish. With the 1 foot, you can see just to give you an example, we're using the 500 megahertz channel, and we're choosing a region K, and we want to provide 5.9 link availability. And you can see this gives you the idea about what it can do. You can see on the BPSK mode, the capacity will be about 360 megabits. Depending on packet size, it could go up to 442 megabits, and your link availability will be 4.9. And your feed margin is 40 dBi, 40 dBm. And when you go with higher modulation, your feed margin start to decrease, and also your link availability start to decrease. So if you're running on like 3.5 or close to 3.5, you're gonna running on the 64 QAM mode, and that give you the distance is in this case the distance is 1.15 miles or 1.84 kilometers, and the capacity is 2.5 gigabits full duplex. So kind of like this is waterfall by distance, by link availability with modulation change. When I do the 2-foot antenna, so same chart, similar concept. The only difference is this one changed from 1 foot to 2 foot. You can see is if I'm running on the 3.5, I'm running on a 2 miles or 3.24 kilometers distance for a link. And my capacity on 64 QAM is 2.5 gigabits. When I start to lower my modulation, like in the BPSK, it's a 362 megabits throughput. And when you're running on different capacity, depends on you're running on ACM mode or fixed mode. This is corresponding the capacity radio will provide, and you can buy different capacity key. Depends on what capacity you need. And for we have a 2.5 gigabits capacity. We have another one is 1.6, and then anything below we're using the same capacity like the 820. We have the 650 meg and 500, 300, depending on the channel size and modulation you're gonna choose. And all of this information is in Link Planner. When you use the Link Planner to plan the link, it will give you the information. The Link Planner support for 820E will be actually later this month. So when you get the Link Planner, you will be able to run the link planning for your link. So let's talk about the multiband. As I said earlier, 820E we support layer 1 aggregation. This is important when we run the multiband. The reason we need a multiband is because the millimeter wave radio gives me the high capacity, but also you can see from previous use case 1 foot and 2 foot, the distance is pretty short. So we only talk about 1 or 3 kilometers distance with millimeter wave radio for high capacity. If we would like to run a little bit further down on the range, we have to sacrifice link availability, and many people, they want a certain link availability to be guaranteed, and the millimeter wave radio cannot achieve that. Simply because of the feed margin is not high, the feed is pretty depth in the ring condition. So a combination with microwave with millimeter wave radio, it will give us the combination for high availability and high capacity. Literally, in a good day, when everything's okay, we're gonna running the capacity of both. So the capacity is a combination for microwave and millimeter wave radio. In a bad day, when there is heavy rain or fade, when we lost the millimeter wave radio, we will leverage the microwave radio to provide the capacity. So here's an example. Let's see. Here's a deployment. I have an example later. So how we do this? Basically, if you look at the radio deployment, we have the 820E here as the the main radio, and from this radio, we have using the SFP interface to provide the connection to your router, and an 820E will support layer 1 aggregation. From here, we have a jump cable to connect our E-band radio with our licensed microwave. It could be 820C or 820CHP or 820S, Depends on what capacity you want to run. And today, for multiband, we support the 80 gigahertz with 18 and 23 gigahertz. Meaning is we will offer a single antenna. The antenna is a multiband antenna. So in this case, this antenna support both 18 gigahertz with 80 gigahertz or 23 gigahertz with 80 gigahertz. And when you do the alignment, using the microwave to the alignment, and then then you will get the things aligned, and you can put everything together with direct attachment. This will be a sort of this is the when we separate them, you can see how things is assembled, and this is the finished picture. Your antenna is attached with the E-band radio, and the A20C is on the side to attach with the antenna as well, but it's on the side. And then you have a single cable go down for the connection. Okay, so when you do this, here is one example. We're using the it's a 2.8 mile distance, which is about 4.5 kilometers range. When we have this link deployed, we're using the A20E, basically provide a high capacity. Majority of the time, like 99.9% of time, we're running on the high capacity with the combination for E-band and the microwave. If the microwave give us like 1 gig, and the E-band give us 2.5 gig, add them together, basically I have a 3.5 gig capacity running overall. And during the bedtime, which is let's say if we running on 3.5, then we have about 3 hours for a year. When we lost the E-band or get a low capacity on the E-band, the A20C microwave will take over. Basically, because this link will still survive, all the data will be received through the microwave and follow the common QoS control. So low priority data will be dropped, high priority data will be passed through. And for a year, for a short period, we're going to leverage A20C to provide the connection. All right. And for the rest of the year, I'm going to leverage both to provide high capacity. When we do this, you can see we can do a 2.8 mile or 4.5 kilometers link with a reasonable distance and with a reasonable link availability and high capacity. And this is what A20E can bring to us. With that, I think that's the end for today's A20E product overview. I'm not sure how many customers, how many people audience today here is from North America. You can talk with you because we do have a special program for A20E Permo. To please talk with your distributors or resellers to find more details about the program. That is specific for North America. All right. By now, I'm gonna see if we have any questions from audience, and we will try to cover that as much as we can. So Susan, do you have any questions in the panel?
No, I don't have any. Just someone wishing us good morning. But if anyone has any questions, please type them in the dialog box, and I will read them to Alan, and we can get them covered. Otherwise, this was recorded, and it will be posted to our YouTube page and our community forum.
All right. So it seems like we don't have any further questions, but if you do have questions, you can post the question into the our Cambium community forum as well. We will monitor that one and give you the feedback. Or you can replay the video, replay the webinar to see if there's any additional question you may have. You can contact us as well. With that, thanks everyone. You all have a good day.
Thank you, Alan. Thank you, everybody.
Thank you, Susan. Bye.